Yeah, so let me start with the rules you have already seen in the previous video. So I'm going to explain straight away the fourth part. Now, if you read the question, you have to prove the identities. And last time I had told you that you can either solve LHS to RHS or you can solve RHS to LHS, right? So here what I have done is I have taken the question is 1 plus sec a by sec a has to be proved equal to sine square a upon 1 minus cos a. You can refer to the textbook and see the question. So you can all solve LHS RHS separately and get a common solution. But what we have done in this case is we have solved the RHS. Now this is the RHS, sine square a upon 1 minus cos a, right? This is the RHS. Now we have done the identity that sine square is 1 minus cos square a. 1 minus cos square a. So it's already in sine cos. So I'm using an identity to convert into cos. Now this is an algebraic identity. This is in the form of a square minus b square. So I've written it in the form of a plus b, a minus b. So 1 plus cos a into 1 minus cos a, right? And denominator is 1 minus cos a as it is. So what happens is that we can cancel out 1 minus cos a. Okay, so what are we left with? 1 plus cos a, right? Now cos is the reciprocal of sec. So what we can do is replace cos a with 1 by sec a. And if you take the LCM, this will become sec a plus 1 by sec a, which is equal to the LHS. So in this question, what we have done is we have solved the RHS and we've got the LHS, right? Now, this is a very important question, this fifth part. Kindly mark this important. This is one of the important questions and is asked normally in the board exams often. So this is a question which is slightly different from the previous because here there are 3 terms, right? So there is no question of solving it as we did 1, 2, 3, 4 because it's already in sine cos. We cannot take LCM. And if you look at this question, the RHS is cosec A plus cot A. You have to prove that this is cosec A plus cot A. So I need to explain this to you. So let me take out the board. So here the question is prove that, okay, prove that cos A, prove that cos A minus sin A plus 1 upon cos A plus sin A minus 1, okay, this is plus, has to be proved equal to cosec A plus cot A. So this is my question, right? So as I told you, this is an important question. So I need to explain to you in detail. Now, this is already in sine cos and this is in cosec cot. So what we need to do is convert this in terms of cosec and cot. Now, if you remember, what is our cosec? Cosec is the reciprocal of sine. And what is cot? Cot is the ratio of cos and sine. So what is common here is sine. Sine A is common in the denominator, right? So what I'm going to do is that I'm going to divide each term by sine A. Divide each term by sine A. Why am I dividing each term by sine A? Because when I divide each term by sine A, I'm going to get all these terms in terms of cosec and cot. Because cosec is what? 1 by sine and cot is cos by sine. So denominator is sine. So that's why I've got the clue that I have to divide by sine. So what I need to do is divide each of these terms by sine. So I'll get cos A by sine A minus sine A by sine A plus 1 by sine A, right? Whole upon, here also I'm going to divide. So this will become cos by sine A plus this is going to become sin A by sin A minus 1 by sin A. Now look at what is going to happen when we do this. So cos by sin we know is cot. So we've got here cot A minus sin A upon sin A. When you divide equal quantities, that's 1 plus 1 by sin A, that's going to be cosec A, right? So we get cot A minus 1 plus cosec A. And the same way here, this is going to become cot A, this is going to become 1, and this is going to become minus cosec A. So if you look at the RHS, we have already got cosec and cot here, and here we are getting cosec and cot, So these are the terms which we require. So don't replace these terms. So what we need to do is get rid of this one. We need to get rid of this one because here the RHS is only in terms of cosecant cot. So for this, you should remember the identity. Okay, just note this, that cosec square minus cot square is equal to 1, right? Cosec square A minus cot square A is equal to 1. This is an important identity which we did. Cosec square A minus cot square A is 1. So that means 1 can be replaced with cosec square minus cot square. So what we are going to do in the next step is leave the cot A and cosec A as it is. So I'm going to write in the next step cosec A plus cot A as it is. I'm not disturbing these two terms. Minus the 1 I am replacing with cosec square A minus cot square A. Reason I told you, based on the identity, cosec square minus cot square is 1. Upon, let the denominator be as it is. The denominator was cot A plus 1 minus cosec A, right? Now this is an identity A square minus B square, so I can write this in the form of A plus B, A minus B. Okay, so in the next step, what we'll do, we are going to write this as cosec A plus cot A as it is, minus, I'm going to replace this as cosec A plus cot A into cosec A minus cot A. Okay. Denominator will remain as it is, that is cot A plus 1 minus cosec A. Okay, so this is A square minus B square, A plus B, A minus B. Now you see this term, cosec A plus cot A, here also cosec plus cot A, this is common. So when I'm going to take this common, when I'm going to get this common, so I am taking the common factors. This is common and this is common. So cosec A plus cot A is common. So take cosec A plus cot A common. So when you take this cosec A plus cot A common, what is happening here? You're taking out everything from here. So what is left here is 1 minus, this is already taken out. Okay, cosec A plus cot A, this value is already taken out. So what is left here is cosec A minus cot A, but there's a negative sign outside. So what will happen? This minus and this cosec will become minus cosec A. Okay, and minus here and the minus cot A, this is going to become plus cot A. Upon denominator as it is cot A plus 1 minus cosec A. Okay, so this part I'm explaining again. So suppose you are having x minus xy. Okay, let us assume that this is x and this is minus x into y. So when you take out x common, what is left here? 1 minus y. 1 minus y. Okay, so when you take out x, 1 is left here. X 1s are x. When you multiply this, you have to get back this. So here cosec A plus cot A is common. So when I take out cosec A plus cot A, don't tell that nothing is left. It will be 1 here because when I multiply this, I have to get back this. So 1 will be left. Okay. So just like I explained here, if x is taken out, then 1 will be written here. So here cosec A plus cot A 1. And this is an important thing to note. There's a negative sign here. This is already taken out common. So minus cosec A and minus will become plus cot A. Now this becomes simple because this and this will get cancelled. These are identical terms. 1 minus cosec A plus cot A plus 1 minus cosec A. The order is different, that's all. Otherwise, these are same quantities. So what are we left with? We are left with cosec A plus cot A, which is equal to the RHS. So hence we are proving that the LHS is equal to RHS. So hope you understood this. So you may note this because this is an important question, one of the important questions from the chapters based on identity. Right? So next we are going to the 6th question. You can note down this in the meantime. The 6th question is on your screen in a moment. Yeah, that's right. So here we have a question which is based on rationalization. Okay, there's a different type of question. So here we have a question, root of 1 plus sin A upon root 1 minus sin A is equal to sec A plus tan A. Okay, the question is root 1 plus sin A. Okay, let me take out the question here. The question is root of 1 plus sin A upon root of 1 minus sin A has to be proved equal to sec A plus tan A, right? So this is in roots. Now in class 9, you've done a process of rationalization. So we are going to make use of that. So we get root 1 plus sin A upon 1 minus sin A. We are going to multiply and divide by the same number as the denominator, but with the opposite sign in between. So this is minus, so we have put plus. I hope you remember this. In class 9, you have done this. 1 by root 3 minus root 2. How did we rationalize? We used to multiply and divide by root 3 plus root 2. So this you already did in class 9. So I'm using that concept of rationalizing the denominator, multiply and divide by the same number but with opposite sign in between. So when you multiply root 1 plus sin A, root 1 plus sin A, the root goes away, you are left with 1 plus sin A. And denominator will become A plus B, A minus B, that is A square minus B square, 1 minus sin square. So here the root is going away because the numbers are same. Okay, so when you multiply same numbers within roots, root 2 into root 2, you will get 2. Root 3 into root 3, you will get 3. Okay, but here the root will remain because these are different numbers. So if I'm going to multiply root 2 into root 3, the answer will be root 6. The root remains. So that is why in the numerator the root has gone, but in the denominator it remains. So this is going to be 1 plus sin A upon root 1 minus sin square A will be root of cos square A. This is an identity. 1 minus sin square we can replace with cos square. So finally we get the answer as 1 plus sin A by cos A. And this cos A that we are getting is for both. So we'll separate the terms. We get 1 by cos A plus sin A by cos A. Okay, this denominator is for both the terms of the numerator. Now we get the answer 1 by cos is sec and sin by cos is tan. So we have got the answer LHS equal to RHS. So hope it is clear. So the sixth part was based on a process which you did in class 9, that is the process of rationalization as explained, and then you get the RHS. Okay, so we move on to the next one now, the seventh part. Okay, the seventh part is pretty simple. You have the question as sine theta minus 2 sine cube theta upon 2 cos cube theta minus cos theta. This is the LHS, right? And we have to prove that this is equal to tan theta. So what is the first step is you're going to take sine theta common. So when you take sine theta common, you are left with 1 minus 2 sine square theta in the numerator. You're removing 1 sine theta. So what is left is 1 minus 2 sine square theta. Similarly, here we are going to take cos theta common. So when cos theta is common, we'll get 2 cos square theta minus 1. Now, instead of 1, we can replace it with sine square plus cos square, right? So this is going to become sine square theta plus cos square theta minus 2 sine square theta. And same way, this is going to be 2 cos square theta minus 1. Again, 1 is replaced with sine square theta plus cos square theta. But when there's a negative sign outside sine square plus cos square, what is going to happen? The signs will change and you're going to get minus sine square and minus cos square. So here when we solve this, we are going to get cos square and sine square theta minus 2 sine square theta will become minus sine square theta. So we get cos square minus sine square in the numerator, and 2 cos square theta minus cos square theta is cos square theta. So we get cos square minus sine square here. So what happens is that these terms are identical, they'll get cancelled. So we get sine upon cos, which is equal to tan. So I hope this is clear. Just take common and then replace 1 with sine square theta plus cos square theta. Moving on to the 8th part, we need to prove that the LHS sin A plus cosec A whole square plus cos A plus sec A whole square is 7 plus tan square A plus cot square A. So what am I going to do? I'm going to open the bracket. I'm going to use the formula A plus B whole square. Identity, algebraic identity you've been learning from the lower classes. So a plus b whole square is a square plus b square plus 2ab. Open this bracket. Open the second bracket. A plus b whole square is a square plus b square plus 2ab. Open the second bracket as well. Now here, this is sine square theta, right? Sine square theta here, and there is a cos square theta here. So this sine square and cos square, I'll replace it with 1. Now cosec square theta is an identity we can replace with 1 plus cot square. So cosec square I'm replacing with 1 plus cot square. Now 2 sine A into cosec A. Now what is cosec? Cosec is 1 upon sine. So 1 upon, if I replace, they have missed out one step here. So it's better that you write in the next step. Cosec is 1 by sine. So sine and sine will get cancelled. So what are you left with? You're left with that 2. So this we have already taken with sine square and got 1. Now sec square. What is sec square A? Sec square is 1 plus tan square. And same way here, sec can be replaced with 1 by cos. So cos gets cancelled and you're left with 2. Now why are we doing all this? Because we want in the RHS in terms of tan and cot. So that is why cosec square we are replacing with 1 plus cot square. And same way sec square A we are replacing with 1 plus tan square A. Now if you count all this, you get 1, 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 2, 7. So final answer we get 7 plus cot square A plus tan square A, which is what we have to do, right? So finally we are going to the last 2 parts. Let me first explain to you the 9th part. So simple one again, cosec A minus sin A has to be proved into sec A minus cos A has to be proved equal to 1 upon tan A plus cot A. So if you look at the LHS, LHS is cosec A minus sin A, right? Cosec A minus sin A. So cosec is replaced with 1 by sin. Cosec is replaced with 1 by sin and sin is replaced as it is. Then in the question we have sec minus cos. So sec is replaced with 1 by cos. Sec is replaced with 1 by cos. So here actually the question has cosec A minus sin A into sec A minus cos A, right? So what are we doing? Instead of cosec, we are replacing with 1 by sin, and sec is being replaced with 1 by cos, right? Hope it's clear now. And now what am I going to do? I'm going to take the LCM here. So LCM will become 1 minus sin square by sin, and this is going to be, because cos A upon 1 can be written as sin A upon 1. So this is going to be 1 minus cos square A by cos A. So 1 minus sin square is cos square, 1 minus cos square is sin square. So what happens? You will cancel out 1 sin A and 1 sin A from here, cos A and 1 cos A from here. So this is cos square A. So what is left here? There is a cos A left, right? Only 1 cos A is, because what is the meaning of cos square A? Cos A into cos A. So when I am cancelling this cos A, 1 cos A will be left here. Similarly, sin A cancels. So 1 sin A is going to be left here. So finally we get sin A upon cos A, right? So this is the RHS that we are having at the moment. But we need to get it equal to 1 upon tan A plus cot A. So what we can do is that the denominator of sin A cos A is 1. So instead of that, I am writing here sin square plus cos square. Okay. And now I want to convert into tan and cot. So what I'm going to do is that I'm going to divide, the numerator has to be 1. The numerator has to be 1. So how do I get here 1? I will divide each of these terms by sin A cos A. So when I'm dividing this by sin A cos A, this is going to come 1. When I'm going to divide sin square A by sin A cos A, okay, then what is happening? Then sin A and sin A gets cancelled. So we get sin by cos, which is equal to tan. And here I'm dividing cos square A. I'm dividing cos square A by sin A cos A. So what's going to happen? 1 cos and 1 cos gets cancelled. We get cos by sin, that is cot. Okay. So after this step, what we need to do is look at the RHS. In the RHS, we wanted 1. So when we wanted 1, the easiest way is to divide the term by itself, because any number by itself is 1. So we are going to divide each term by sin A cos A and we get the required result. Okay, so we move on to the last question then, the 10th part. Prove that 1 plus tan square A upon 1 plus cot square A is equal to 1 minus tan A whole square upon 1 minus cot A whole square is equal to tan square A. Okay, we have to prove that the first, second part is equal to tan square A. So this is the first part, we are doing this. So 1 plus tan square A upon 1 plus cot square A. So this is an identity, 1 plus cot square A is sec square A and 1 plus cot square A is cosec square A. This is the identity, you are already aware of this. Now after this, so after this step, the sec is, replaced with 1 upon cos square. Sec is the reciprocal of cos, so I can say sec is 1 by, sec square A is 1 by cos square A. And what is cosec? Cosec is the reciprocal of sine, so this will become 1 by sine square A. So if I'm going to solve this, the lowest number goes right on top, so I'm going to get this as sine square upon cos square A, and that's how you get sine square by cos square is tan square. Okay, so I hope that is clear. So first I'm using the identity 1 plus tan square A. I've replaced with sec square A. 1 plus cot square A is cosec square A. Then I've replaced sec as 1 by cos. So this becomes 1 by cos square. Cosec I've replaced with 1 by sine. So this becomes 1 by sine square. When I take the reciprocal of this, sine square goes right on top. So this becomes sine square by cos square. And sine square by cos square we know is tan square. Right? So that's the first part, and then there is also a second part to this. So let me come to the second part. Yes, so this is our second part. The second part is that prove that 1 minus tan A by 1 minus cot A whole square is equal to tan square A. Okay, we need to prove that it is equal to tan square A. 1 minus tan A upon 1 minus cot A whole square has to be proved equal to tan square A. So I would suggest doing this by a simpler method. So this is going to be 1 minus tan A upon 1 minus cot A whole square, okay, has to be proved equal to tan square A. So what I would suggest in this question is to convert into sine cos. That's easier. So I can convert tan as sine by cos and cot as cos by sine. Okay, converting into sine cos. Then I'm going to take the LCM. I'm following my normal steps. So this will become cos A minus sine A by cos A, and this is going to become sine A minus cos A upon sine A whole square. Now this cos A minus sine A and sine A minus cos A, when you square it, it is the same thing. Okay, 5 minus 3 whole square and 3 minus 5 whole square is same. 5 minus 3 whole square and 3 minus 5 whole square is same, because this is going to come 2 square, which is 4, and 3 minus 5 is minus 2 whole square, that's also 4. So this will come same. There's no difference when you square it. Otherwise there's a difference. 5 minus 3 is 2 and 3 minus 5 is minus 2. But when there is a square, it doesn't matter. So I can cancel these terms because there is a square. And now what happens? The lowermost number comes right on top. So you are going to get sine A by cos A whole square, which is equal to tan square A. So we get the term which is required. So there were actually in this question slightly different. There were 3 parts. No, we have 1, 2, and 3. So first case, what did I prove? I proved that 1 is equal to 3. And in the second case, what did I do? 2 is equal to 3. So first I had proved 1 and 2 equal. Now I have proved 2 and 3 equal. So what is the conclusion? That all the 3 parts, 1, 2, and 3 are equal to each other. So with this, we complete all the 10 parts, and I hope the identities are clear to you. In the next video, we'll be doing the applications of trigonometry. That is a much simpler chapter as compared to this, because you will be using only specific angles 30, 45, 60. and there are some basic concepts involved, and there's only one exercise. So we should be able to do that very soon. So in the meantime, what you can do is go through these identities and learn of the values, especially of 30, 45, and 60, so that you're prepared for the next class. So that's it for this. So we can call it a day for today. Thank you.